Hi Albert, what is the today topic?
Hi Daisy, today we have invited Dr. Fridolin Ting to talk about higher derivative.
Do you know what have happened? Did he drive over speed?
I don't know. We need to calculate the velocity and acceleration. Maybe we need to learn higher derivative, since velocity and acceleration are first and second derivatives of the distance versus time function.
Before you start to learn higher derivative, you shall have some basic knowledge on first derivative such as differentiate a polynomial function and some basic differential rules.
Please spend several minutes to answer the diagnostic test. If you can't answer the diagnostic test, you need to read the supplementary notes. Now, Dr. Ting would come to talk about higher derivatives.
Now, what are higher order derivatives? So suppose you have a function y to f of x, and that function is a differentiable function, which means dy dx is f prime of x, just notation, right? And this f prime of x is called the derivative function. Now, suppose that the derivative, as you know, is a function itself, right? F prime of x. So suppose that derivative function itself is differentiable. Okay? So you can differentiate that function again. Okay? So that is, you have so if f prime is a differentiable function, remember f prime is a function itself, right? So if the derivative is differentiable, then we can differentiate again, right, by taking the derivative of the derivative. And we're going to notate it, denote it by f prime of x, or f superscript 2 of x, or just d squared y over dx squared. So these are all notations for the second derivative, which is the derivative of the derivative function. And similarly, so now this second derivative, okay, which is the derivative of the derivative, is itself a function, which is of course called the second derivative. If the second derivative function is differentiable, then you can differentiate that function and get a third derivative. Okay, so the third derivative is denoted by f triple prime of x, or f superscript 3 of x, right? Or just d cubed y over dx cubed. So in general, you can go on and on, and you can have the nth derivative of a function if it's n times differentiable. And we call the nth derivative of f as the nth order derivative of f. Suppose your function f equal to x to the power 6. What's the derivative of x to the power 6? By power rule, it's just 6x to the power 5. Now, of course, 6x to the power 5 is differentiable itself, right? So you can differentiate it again to get the second derivative of f, which is 6 times 5 by power rule again, x to the power 4, right? Which is 30x to the power 4. And since the second derivative is differentiable, then you can take another derivative to get the third derivative, which is, so 30 times by power rule again is 120 x to the power 3. You can go on and on. So the fourth derivative is the derivative of the third derivative, which is 360 x squared. And then the fifth derivative is the derivative of the fourth derivative. So that's going to be 720x. And finally, the sixth derivative is going to be 720. And in fact, the seventh derivative of x to the power 6 will be 0. So if you want a nicer notation, I summed it up here. Just double check they're the same. What about, so there's some notation for higher derivatives, which we call Leibniz notation. So this is where that notation d squared y over dx squared comes from. Okay? It's called Leibniz notation for the second derivative. So it's the derivative of the derivative, right? So this is the derivative. Similarly, you can denote the third derivative as d cubed y over dx cubed as the third derivative, which is the derivative of the second derivative. Okay? And so on and so on. You can denote the nth derivative with respect to y as dny dx to the power n, which is the derivative, right, of the nth minus 1 derivative. Dx to the power n minus 1. Right, okay. So let's do another example. So what's the derivative of x to the power 4 minus 3x squared plus x? Well, just by sum and product power rule, it's just 4x cubed minus 6x plus 1. This is going to be... So what's the second derivative of the original function? Well, that's going to be the derivative of the first derivative, right? So d by dx of the first derivative. Y, of course, we're assuming is our x to the 4 minus 3x squared plus x. Right? So this is derivative, but the derivative of the derivative is, this is exactly goes into here. So we take the derivative of the top, the derivative, which is then just 12x squared minus 6. Right? And finally, the third derivative is just the derivative of the second derivative. Right? The second derivative, which is exactly this guy here. Put into here. Right? So then you get the derivative of this is just 24x. Okay. My writing is quite messy, so this is a nicer representation here. Now, what about x to the power minus 1? So we call this, say, f of x. Okay. Then f prime of x is just, so again, by power rule, just minus 1, right, times x to the power minus 2. What about f double prime? Well, that's going to be minus 1 times minus 2, x to the power minus 3, right, by power rule. F triple prime, minus 1 times minus 2 times, is a 2, minus 3, x to the power minus 4. You can see a pattern. X to the power is going to be, so there's, in fact, here there's 1, right, to the power 1, x to the power minus 1. Here it's going to be minus 1 squared, right, times 1 times 2, x to the power minus 3. This is 2, sorry. And here, see, there's minus 1 to the power of, so 3. 1 times 2 times 3, x to the power minus 4. So you see a pattern. Minus 1, the fourth derivative will be, so here, see, minus 1 is power of 1. This is first derivative. Second derivative, you have minus 1 to the power 2. Here, third derivative, you have minus 1 to the power 3. So fourth derivative must be, right, to the power 4. And then you have 1 times 2 times 3 times 4, right, times x to the power minus 5. And you can also see a pattern in the powers of x, right? So first derivative, x to the power minus 2. Second derivative, x to the power minus 3. Third derivative, x to the power minus 4. Fourth derivative, x to the power minus 5. So in general, you can go on, and in fact, fn of x is actually equal to minus 1 to the power of the same order of the derivative, which is, you can see, right, because x right here, so to the power n. And this product is in fact n factorial. N factorial. And this is x to the power minus n plus 1. You add 1 to the order of the derivative. So that's the general formula for the nth derivative of f of x is equal to x to the power minus 1. Okay. Again, my writing might be too messy, but this is a nicer representation. And finally, let's find the fifth derivative of, so this cosine 2x. So this is much more straightforward. So for example, so f prime of x then would just be minus 2 cosine by chain rule 2x. Oh, sine, sorry. Sine, oops. Sine 2x. Oh, let's just erase. Sine 2x and f their second derivative. So minus 2 times 2 is it's minus 4 cos 2x by chain rule again, right? F3 third derivative. So cos derivative, cos is sine, so it's, and then you take 2 out, so it's 8 sine 2x. Fourth derivative, so 16 cos 2x, and then fifth derivative finally, just minus 3, because derivative cosine is minus sine, right? So sine 2x. That's it. So you can find some other lecture videos on Khan Academy and higher order derivatives and applications at the following YouTube videos.